Hello, geometry students. In this video, we will learn about circles, the vocabulary, and central and inscribed angles. And at the end, we'll be able to solve for measures of central and inscribed angles of circles and their intercepted arc measure. If you just read that sentence and said, I don't know what any of those words mean, well, that's why we're going to start with some vocabulary. Okay, so some stuff you already know about circles. Let's review some of the stuff you already know and introduce some stuff that you might not know. A circle is a set of all points that are equidistant from a given point called the center. And this example right here, the center is C, and all of these points around it are the same distance away from that center point C. We name a circle by that center point. We give it a little symbol and C. If the center of the circle were the point Q, then it would be circle Q. You name a circle by its center. A radius is a segment or length from the center of the circle to the edge of the circle. Now in this circle right here, I've drawn in CR. That's not the only one we could draw in. We could draw in a bunch of different radii. We could draw one to the left, one to the top, one to the bottom. There's infinitely many radii, it's the plural of radius, that you could draw on a circle. Anything that goes from the center to a point on the circle is a radius. We name a radius, since it is a segment, we name it by its two endpoints. This one right here would be CR and give it a symbol that looks like a segment. You could also switch the endpoints and call that RC if you wanted to. A diameter is a segment with both endpoints on the edge of a circle, and it passes through the center. For example, this one right here, DR, it goes through the point C. This isn't the only one. You could draw infinitely many diameters on the circle as well. You could draw one straight up and down and all kinds of angles. There's no limit to the number of diameters you could draw. How do we name it? Since it's a segment, we name it by the two endpoints. In this case, D and R. And since it's a segment, we give it a little segment symbol. Now, even though there's a center point here, if it's a segment, we only ever use two letters to name a segment. You could switch R and D if you wanted to. The endpoints can be in either order, but we only use two letters to name a segment. So two letters for a radius, two letters for a diameter. Next, we have some other type of segments. A chord is a segment with both endpoints on the edge of the circle. It doesn't have to go through the center. Maybe it goes through the center. A diameter is a special type of chord, but any segment that has endpoints on the edge of the circle is a chord. In this case, we would name it by those two endpoints. We would call it AB and give it a segment symbol. A secant is a line that hits the circle at 2 points, and it goes outside of the circle. So it's not just a chord. Chords start and stop on that circle. A secant goes past it. Maybe it goes past it in both directions, but definitely going in one direction. And this one we would label it MN. If this is a segment, then we would just give it a segment. If it was a line, then we would give it a symbol to indicate that it was a line. A tangent is a line or a segment that hits the circle at exactly 1 point, and that's called the point of tangency. Like this one down here, it's not going through it, it's only touching it once, so tangent. We'd name this one TG. If it's a segment, we give it a segment symbol. If it keeps going and it's a line, then we would give it a line symbol. Now let's talk about arcs. We have a minor arc, a major arc, and a semicircle. So I should mention that a circle has 360 degrees in it. A semicircle, half of that, is 180 degrees. We talk about minor or major arcs in relation to, are they less than half of a circle or more than half of a circle? A minor arc is like it sounds, small. It's a portion of the outer edge of the circle that measures less than 180 degrees. A major arc is a portion of the outer edge of the circle that measures more than 180 degrees. So minor is less than half a circle. Major is more than half a circle. We'll talk about naming in just a moment. And a semicircle is an arc that measures exactly 180 degrees. So we name them differently because they represent different things. A minor arc, if we just wanted to connect this point here, like from A to C, just this short distance here, less than 180 degrees. That's a minor arc. We would name it with two letters, the endpoints, AC. And we give it a little symbol that looks like an arc. We don't want to give it a segment symbol because it's not a segment. It's a part of the outside of the circle, which is round. A major arc is more than 180 degrees. If we wanted to get from A to C, but not this short distance, if we wanted to go all the way around going through B, then this would be a major arc. Sorry, I can't draw circles very well. And we would name this with 3 letters. We name the endpoints and then a point that it goes through along the way. A, B, C. Now for a semicircle, it's exactly 180 degrees, and we do use 3 letters to name that so that we know which part we're talking about. If we wanted to talk about this upper half of this circle right here, this upper semicircle, it starts at W and ends at Y, and it goes through X. So we would name this WXY and give it an arc. If we wanted to talk about the bottom semicircle, it still starts at W and ends at Y, but this one doesn't go through X, this one goes through Z, so we would name that WZY, and we do want to give 3 letters for a semicircle to make sure we know which portion of the circle we're talking about. Okay, take a moment here and see if you can identify, use the circle to name, how do we name the circle? Name a radius, a diameter, a chord, a secant, and a tangent. I encourage you to pause the video, think those through, and then resume it to see if your answers match what we have here. Okay, so this circle, the center is B, so we would name it Circle B. A radius, there's 2 of them here we could choose from. We have CB or BD. Either of those would work. Make sure to give it a segment symbol. And you could switch those letters around if you want to. This could be BC, this could be DB. Diameter goes all the way through the center. We only use 2 points to name it though. C and D are the endpoints, so our diameter would be CD. A chord has endpoints on the circle. CD would work as a chord, but we also have this one down here, EF. The segment EF that starts at E and ends at F has endpoints on the circle, so that's a chord. A secant goes through it and touches it in more than touches it in 2 places. That's EF, just that part of the segment is a chord, but EG, the entire segment there, goes outside of the circle, so that EG would be a secant. And a tangent touches the circle in only 1 place. That's this segment up here, HJ. Okay, now let's talk about 2 types of angles in a circle. The first one is a central angle. A central angle is an angle whose vertex is located at the, you guessed it, center of the circle. Makes sense. Central angle, vertex at the center. So what we have here, this angle right here, that's a central angle. Forget my little stray mark there. And this may be X. Well, the central angle creates a part of the circle out here that's called its intercepted arc. And that would be this portion of the outside of the circle here. It's called its intercepted arc. And there is a relationship between the central angle and the intercepted arc, and that's that they are equal. Whatever the central angle is, the intercepted arc is the same. Whatever the arc is, the central angle is the same. So that relationship is that a central angle is equal to its inscribed arc. Excuse me, intercepted arc. I'm sorry. Okay, so let's take a look at a few problems. Here we want to find the value of the question mark. And what we have here in this first example, we are trying to find an arc, and we know the angle. And this arc has the same value as the central angle here. So if this central angle is 122, then this intercepted arc is also 122 degrees. For our next one over here, we're trying to find the measure of this angle right here. Now there's a lot of pieces here. There's 3 numbers. How do we know which one to use? Well, I've extended my sides here, and we're just going to take the one that is the arc that is in between those. And if this arc is 140 degrees, then this central angle is also 140 degrees. Well, what if we have some algebra? Same idea. Here we have 10x plus 5, and this is a central angle, and that central angle is equal to this intercepted arc. So that central angle is equal to 85. So 10x plus 5 equals 85. Now you can use algebra or you can use Desmos to solve this. Remember, if you're using Desmos, type it in. Always use x as your variable, and you're looking for where you get the vertical line. I'm going to use algebra on this one, though, because it's nice enough. If we subtract 5, then we get 10x equals 80. And when we divide by 10, we get our solution, x equals 8. Our next problem over here, our variable is here. It's this arc is 110x plus 1. And this intercepted arc goes with this central angle right here. It's 111. So those two are equal. Our 110x plus 1 equals 111. Use algebra, use Desmos, does not matter. Just be able to figure out that relationship and then be able to solve. I'm going to use algebra. We get 110x equals 110. So it's a nice one. When we divide, we get that x equals 1. Now, what about these other numbers here? We didn't need to use this. Sometimes there will be pieces of the circle that we don't need to use. So that's what you need to know about a central angle. Now, let's talk about another kind of angle called an inscribed angle. An inscribed angle is an angle whose vertex is located at the edge of the circle. Its vertex is on the circle, not at the center. So we have an example right here. We've got our angle, and that vertex is on the circle right there. It also has an intercepted arc. And that intercepted arc is this part right here of the outside edge of the circle. Now there's a relationship between these two parts, but it's not the same as a central angle. An inscribed angle is half of its intercepted arc. So this might be x for our angle, and then the arc would be 2x. And I'm going to write that in two different ways, actually. The first way is saying that the inscribed angle is equal to half of the intercepted arc, or the intercepted arc divided by 2. For example, if we had something down here where we knew we had an inscribed angle, if we knew that this arc was, let's just say 100 degrees, then the inscribed angle would be half of that, which is 50 degrees. But what if we knew something different? What if we knew, I'm just drawing here on the circle again, same circle. What if we knew that this angle was 40 degrees and needed to find the intercepted arc? Well, the angle is half of the arc. 40 is half of 80. Another way of saying this would be to say that the intercepted arc is twice as big as the inscribed angle. These are just saying the same relationship. It depends on what you know and what you're trying to find as to which setup you would want to use. Let's practice a couple of problems. Okay, there's a lot going on these pictures right here. Find the value of the question mark. Our question mark is right here. This is an inscribed angle. Its vertex is on the circle. And we have an arc that goes between here. This is the intercepted arc that is associated with this inscribed angle. And that relationship here is that this angle is half of the arc. So half of 66, or 66 divided by 2, and that would be 33 degrees. Over here on this one, we're trying to find the arc. And we have a lot going on, but let's go back to this 50 right here. We can see that we have this inscribed angle here. So our angle is half of the arc, or the arc is twice as big as the angle. 50 is half of 100. So our arc here is 100. Now what if we have some algebra? Same idea as what we did before. Figure out the value and then set your equation and solve. What we have here with the algebra, this is 4x plus 14. This is an inscribed angle, and its intercepted arc is 108. So this angle is half of the inscribed arc. Excuse me, intercepted arc. Mixed up my words there. So half of 108 gives us 54. This angle right here is 54. How much is x? Well, 4x plus 14 equals 54. Use Desmos or use algebra, does not matter. Go ahead and use the algebra here. We get that 4x equals 40. And when we divide by 4, we get that x equals 10. And our last example here, the part we're trying to solve for is this major arc, 13x plus 18. And it goes with this inscribed angle back here that is 100 degrees. So the angle is half of the arc. That means that the arc is going to be twice as much as the angle. So 2 times 100, it's 200. This one is 200 degrees. So we set up our equation, 13x plus 18 equals 200. And then we solve. Subtract and divide. And when we're all done, we get that x equals 14. And that is what you need to know about central angles and inscribed angles. Central angle has a vertex at the center of the circle, and it's equal to its intercepted arc. An inscribed angle has a vertex that is on the circle, and the inscribed angle is half of the intercepted arc. That's what you need to know.